Hi all. In this video, we will be learning about what is collision and how we can resolve it, how it occurs. We have previously seen what is hashing and why it is required. So collision is one of the concept that is involved as a part of hashing. Now, when it occurs basically, so we saw one example in the previous video where we performed hashing to store some 4 values in the hash table of size 5. In certain cases, it may happen that a hash function like division method can return the same hash value for 2 or more data values. So that is possible. Since we are just doing it by the formula, it may be the thing that 2 or more elements or 2 or more data values can generate similar index. And in such a case, we cannot maintain multiple values in one slot or at one index. In such a case, this particular problem will be referred as a collision. Now, how to resolve the collision? So there are different ways to resolve it. So there is first part where it is named as separate chaining. This is one of the collision resolution technique. We'll be seeing it later on. And under open addressing category, there are 3 techniques which can be used to resolve collision: linear probing, quadratic probing, and rehashing. So first we will start with this particular technique called linear probing. So there is this sum that we will solve where it is mentioned clearly that we have to apply hashing. The table size is 10. I have to store all these values in this table. And if there is a collision, then I have to implement linear probing. If it is not mentioned anything about collision, and if collision occurs in our data values, we can implement any of the given techniques based on our choice. But if it is mentioned clearly, obviously we have to go for that particular given technique. So let's start with the solution for this. So first thing that we will do is we will use our hash function, which is division method. So using division method, I need to write the formula h of x equal to x mod table size. Now I need to start with my first value. So h of 89 is 89 mod 10. 89 mod 10 will be giving index 9. Moving to next value, h of 72, 72 mod 10 will give me value 2. h of 10, 10 mod 10 will give me value 0. h of 44, 44 mod 10 will give me value 4. Till now, there has not been any collision. All the values are unique. So now, the next value we have is h of 22. So we will do 22 mod 10 and it will generate index 2. Now, one thing we need to observe here is h of 72 is also generating an index 2. Same is applied to h of 22. It is also giving the same index. Now, this is the case where collision has occurred. So why it will be called as collision? Because index 2 is occupied by this value called 72. But then 22 is also giving me the same location. So I cannot store both 22 and 72 at the same index. So in such a case, I will say that collision has occurred. Now, what I have to do, so as per the question, we have to apply linear probing. So I will say that using linear probing. Now, by linear probing technique, there is one formula that we will be following, and then I'll explain you what linear probing is and what it will exactly do. So the linear probing formula is hi of x equal to x plus I mod table size. So it is somewhat similar to division method. The only difference that we are seeing is with this thing called I. So linear probe is to search and linear is to linearly search, as in search the neighboring slots. So basically linear probing is a technique which checks the immediate slots if they are empty. So since slot 2 is not empty, it already has a value, it will search for the immediate next slot. If that is also full, it will search for the next one, and so on until it gets the empty slot. So that is called as linear probing. So the value of I will be 1, 2, 3 and so on till the size of the table basically. Okay, so now I have to apply this formula on 22 as this is where the collision has occurred. So the first calculation I'll do as h1 of 22 with 22 plus 1 mod table size. So 22 plus 1 is 23, 23 mod 10 is 3. Now let's check if 3 is already used. No, it is not used. Let's do one thing. Just to keep the track of the final index, we will just underline it twice. So here I am underlining the index twice, which is unique. I am not underlined this particular one because it already has a collision. So this is the final index for 22. If 3 is also occupied, I need to do the next calculation, which will be h2 of 22, doing 22 plus 2 mod 10. This is how we will go further until and unless we get an empty slot. Now we are done with 22. We will move to the next value, 50. So h of 50 will be 50 mod 10, resulting an index 0, which again we can see that it is already in use. So I will say collision has occurred. And again we will use the same formula. So I am not repeating formula. I hope you have understood this part till now. So I'll just directly put the values. h1 of 50 equal to 50 plus 1 mod 10. So 50 plus 1 will be 51 and 51 mod 10 will give us index 1. Now 1 again is not already in use, so again it will be a unique index that we can go for. As I said, again if the slot is still occupied, you can go with the next calculation doing h2 of 50, 50 plus 2, 52 mod 10 likewise, so on. So that's it. This is how we have got all the values covered. And now the final and important thing is to draw the hash table. It is very important to put all the values into the hash table. So I am naming it as index and the value that I want to store. So since it is table size 10, it should start from 0 till 9. And now let's write all the values at the given index. So at index 0, we have value 10. Let's just go by the given sequence. So at index 9, we have 89. At index 2, we have 72. So this will be easier to track. 0, we have 10. At index 4, we have 44. At index 3, we have 22. And at index 1, we have 50. So you can clearly understand that since that current slot was not available, it just went for the immediate next slot. If that is not available, it will go for the next one. So likewise, the linear probing is implemented. It is very easy to do if you remember the formula well. And that's it. I hope you have understood it. So now we can move to the next technique, which is called as quadratic probing. I'll tell you why it is required and how it will be done.